Hi all, welcome back to Matlab tutorial on Tooth Fulcrum. This session is on solving basic algebraic equations in Matlab. So to solve the basic algebraic equations, here we'll be making use of the solve function. And for the same, we'll be making use of the symbolic math toolbox. So we have discussed in detail about the symbolic math toolbox in our previous sessions. So let's get started and let's see how to solve the basic algebraic equations in Matlab making use of the solve function. So let's first define the symbolic variable. Let's call it as x. Now we need to define our equation. So let's take a simple equation, say x minus 5. Now we're going to solve for this equation x minus 5. So here I'll make use of the solve function. So I'll say solve and this function takes two arguments. The first one is the equation and the second one is the variable. So here my variable is x. So this is going to solve for the variable x. Let's run the code and verify our output. So you could see the output here, answer equal to 5. That is, the solution for our equation is 5. Let's see another example. Let's see how to solve the quadratic equations in Matlab. So the solve function can also solve higher order equations. It's often used to solve the quadratic equations. Let's take one example. Let's consider our equation x squared minus 7x plus 12 and say we are going to solve this making use of the solve function. So as the first step, we need to define the symbolic variable. So here I'm using it as x. Now I need to specify my equation. So I've defined my equation. Now I'll use the solve function, solve equation, comma the variable. Let me take the solution to a variable, say s. Now here, as you know, since it's a quadratic equation, this is going to have two roots. So let's display them separately. Let's display the first root as well as the second root. So I'll use the disp function. The first root is, I'm going to display it as disp, let's say is of 1. This will give you the first root. Same way I'm going to display the second root. So we are done. Let's run the code and verify the output. So our program works fine and you could see the output here. The first root is 3 and the second root is 4. Now let's see how to solve a system of equations. The solve function can also be used to generate solutions of systems of equations involving more than one variable. So let's take an example. Let's consider two equations, 5x plus 9y equal to 5 and 3x minus 6y equal to 4. Let's see how to solve this system of linear equations. So we could see two variables here, x and y. So as the first step, we need to declare them as symbolic variables. So sims x space y. Now I have declared x and y as my symbolic variable. Now I need to define the two equations. So equation 1 is equal to 5 into x plus 9 into y minus 5. Same way I'll define my equation 2 equal to 3 into x minus 6 into y minus 4. So I have defined my two equations. Now I'll use the solve function here. S is equal to solve of equation 1, comma, equation 2. So you will get values for your x and y. How do you access the same? I'll say s dot x and s dot y. This will give you the corresponding values for x and y. Let's run the code and verify our output. So our program works fine, and this first entity is corresponding to x, that is s dot x. This is the output for s dot x, and minus 5 by 57 is for y, s dot y. So this is how you solve the system of linear equations using the solve function. Now let's see how to expand an equation using the symbolic math toolbox. So let's say we want to expand an equation x minus 5 into x plus 9. So as the first step, since you're using the symbolic math toolbox, you have to declare the variable as symbolic. So I have declared the variable x here as a symbolic variable using the command symsx. Now I'll make use of the expand function to expand this equation. So expand, you can put your equation here as an argument to this function. So you could specify here x minus 5 into x plus 9. So after executing, you could see the output here. It is expanded as x squared plus 4x minus 45. You could factorize an expression using the factor function. So if you want to factorize, say, the equation x cube minus y cube, as a first step, as we have seen before, declare the symbolic variable. So it's x here. Then within the function factor, provide your equation as an argument. So once you evaluate this, you could see the output here. The function or the expression equation is factorized as x minus y, x squared plus x into y plus y squared. So this is about making use of the symbolic math toolbox and various functions to solving the algebraic computations. Thank you so much for watching. Please do like, share, comment and subscribe, and please don't forget to tap the bell icon. You'll get notified whenever we upload a new videos. Thank you.